Mysterious shark behavior before earthquakes. Join us as we explore the fascinating world of shark behavior, uncover the science behind their unique sensory capabilities, and discover how these incredible creatures could help us predict earthquakes. Hey shark enthusiasts, this is Predator of the Deep, your ultimate destination for all things shark-related. Subscribe and stay ahead with the latest shark news and jaw-dropping footage. Today, we're diving deep into one of the ocean's greatest mysteries, the intriguing behavior of sharks before earthquakes. These ancient predators have captivated scientists and enthusiasts alike for centuries. Earthquakes are one of the most powerful natural disasters. They can cause devastation. However, they can be predicted. Firstly, animals start to behave rather abnormally. Perhaps the most captivating of these stories is that of sharks and their tendency to behave eerily before an earthquake. Having previously been viewed as solitary hunters of the ocean waters, sharks display peculiar transformations that have been studied by scientists and researchers from all over the world. An earthquake results from a shift in the Earth's crust accompanied by the generation of seismic waves. This usually emanates from the movement of tectonic plates and can create a considerable amount of ground motion. Seismology, the science that deals with earthquakes, has been developed greatly, but predicting the time and place of the next one precisely is still a problem. There are natural signs that are usually associated with the occurrence of an earthquake. Strange behavior in animals is among them. Knowledge of these behaviors might help improve our ability to forecast the outcomes. Most are fish, characterized by their acute senses such as their ability to use electroreception. They also have the ability to detect electrical fields emitted by other living organisms. This sense is made possible through structures called Lorenzini's ampullae, which are capable of detecting even the weakest of electrical impulses. Dolphins and sharks also employ this ability for their hunting as well as navigation. Moreover, sharks have good hearing and can feel low-frequency sound and vibrations, and thus are sensitive to alterations in water conditions. Earthquake precursors aren't well documented scientifically, says Matthew Blackett, Associate Professor in Physical Geography and Natural Hazards at Coventry University. But some scientists theorize that animals could have evolved a seismic escape mechanism, he says. Perhaps they detect pressure waves before earthquakes arrive. Perhaps they detect changes in electrical field as fault lines when rock starts to compress. Animals also contain a lot of iron, which is sensitive to magnetism and electric fields. Some documents and eyewitness reports have indicated the behavior of sharks before an earthquake. Sharks go on to have uncoordinated moving, quick changes in water depth, and even stampedes. For instance, fishermen and dwellers of coastal seas have cited spotting of the sharks nearer to the seashore or in regions where they have never been seen before within days or hours before the earthquakes. Similar accounts have been recorded about different regions of the world and have further contributed to the glamour associated with the shark and their association with earthquakes. There are many scientific papers concerning the correlation between sharks' activity and that of earthquakes. It is assumed that sharks can feel the alterations in the Earth's crust and currents before the seism, thus being sensitive to its occurrence. Before an earthquake, stress affects rocks to liberate ions in the groundwater that produce electromagnetic fields. Due to their electroreception characteristics, sharks are used to identify these minor shifts. Sharks possess an array of highly developed senses that allow them to navigate and hunt in the ocean. Their sensory capabilities include: sharks' specialized organs enable them to detect electromagnetic fields produced by living organisms and possibly geophysical events. This system allows sharks to detect vibrations and pressure changes in the water, providing them with a keen sense of their surroundings. Sharks have an extraordinary sense of smell, capable of detecting minute blood concentrations or other substances from considerable distances. While not as developed as their other senses, sharks have adapted to see well in low light conditions. These advanced sensory systems may play a role in their ability to detect environmental changes associated with earthquakes. Moreover, trembling sounds that microfractures in the Earth's crust may create before an earthquake. These disturbances are picked up by sharks due to their good sense of hearing. Sharks, especially with their ability to detect chemical signals or pheromones, would be able to sense the changes in the level of some gases such as radon, which would increase due to an earthquake. In March 2011, Japan had to endure a huge earthquake, followed by a tsunami. There were signs of changes in the shark behavior prior to the earthquake. Fishermen and marine biologists of the region reported sharks swimming near the coastal line and displaying unusual behavior. Other observations of animals exhibited strange behaviors before the earthquake, among other signs. There have been significant disasters in Tamil Nadu, with the most recent and worst being the Indian Ocean earthquake and tsunami in December 2004. Before the earthquake, there were reports of unusual shark behavior along the coast of Indonesia and Thailand. Observers noticed that the sharks were moving closer to shallow areas, which may have been an indication of the impending earthquake. Furthermore, experts studying California and the effects of impending seismic events have also collected testimonies of swarming sharks. Sharks may be taken as natural earthquake indicators, a very interesting idea. If the scientific community could substantiate these behaviors and better comprehend the means by which they manifest, it might produce new prognostic tools. However, there are several challenges. It is challenging to obtain regular and credible data on sharks' activities prior to the earthquakes, and it necessitates a long-term surveillance of sharks in all the regions affected by the earthquakes. Finding out the particular actions or behaviors associated with earthquakes and those belonging to the natural behavior of sharks is challenging. The relations between these factors have to be defined and clearly differentiated. Television displays and underwater cameras are important technologies in analyzing the trend of shark movements. Such tools can be beneficial to scientists in the process of data collection because they gather improved quantitative and qualitative data. Likely, joint work of marine biologists, seismologists, and other researchers is one of the most effective ways. Using integrated knowledge of the experts from various sectors would help in coming up with a relationship between sharks and earthquakes. Researchers are using various methods to study the relationship between shark behavior and earthquakes. Satellite and acoustic tags are utilized to monitor shark movements and collect data on their behavior. Instruments are deployed to measure seismic activity, electromagnetic fields, and water chemistry in shark habitats. Sophisticated algorithms and machine learning techniques are employed to analyze vast data sets in order to identify patterns and correlations. Animal behavior data can enhance traditional seismic monitoring, potentially improving early warning systems. By identifying patterns in shark behavior, we may be able to predict the probability and potential impact of earthquakes. Educating communities about atypical animal behaviors as potential earthquake precursors could enhance preparedness and resilience. Furthermore, several challenges need to be addressed to validate the connection between shark behavior and earthquakes. It can be challenging and expensive to gather enough accurate data on shark behavior and environmental conditions. The variability in shark behavior and the occurrence of false positives make it difficult to identify genuine earthquake precursors. To bridge the gap between marine biology and seismology, it's important to have interdisciplinary collaboration and communication. Conducting long-term studies to accumulate comprehensive data on shark behavior and seismic activity. Developing new technologies for monitoring and analyzing environmental changes and animal behavior. Encouraging global collaboration among researchers, institutions, and governments to share data and insights. With this in mind, the eerie activity of sharks prior to the earthquake is still an interesting research. Although one can find several real-life and early scientific investigations that support this relationship, additional large-scale investigations are required to replicate these findings and analyze the processes behind them. If true, sharks' behavior can be used to predict an earthquake and become a means of minimizing the loss of human lives. Continued scientific and technological research eventually helps to study how these prehistoric predators can see the changes on our planet and can warn us about the occurrence of earthquakes. If you enjoyed this deep dive into the world of sharks and natural disasters, be sure to like, comment, and subscribe for more incredible insights into the wonders of our natural world. Don't forget to hit the notification bell so you never miss an update. Thanks for watching, and we'll see you in the next video.